Today we're going to discuss conservation of momentum. Okay? When we talk about conservation of momentum, we have to realize that we're talking about the momentum, overall momentum of a system during a collision. Okay? So the overall momentum of a system, that means all the objects involved during a collision. Okay? Now, some basic things to understand about conservation of momentum is that during a collision, okay, during a collision we're talking about, energy and momentum are conserved, okay, and transferred from one object to another. Which means conserved means that it doesn't disappear. It may change forms. Like if you had a collision, some energy is released in the form of heat, some in the form of sound, okay, and momentum can be transferred to the other object in the collision. Energy and momentum are conserved and transferred from one object to the other in the collision, involved in the collision, okay? Okay. Now, so at the end of the day, right, after a collision occurs, the total amount of energy and momentum will be the same. Okay? During a collision, the total of energy and momentum, I'm going to symbolize that with a P, will be the same before and after the collision. Okay? So, the total momentum of a system of objects does not change. There is the same amount of momentum before the collision as there is after the collision. Okay? Alright, so let's just do a quick little drawing. Alright, if we look at let's say we have a collision about to occur. We have a 20 kilogram square cart moving at 10 meters per second. Okay? And we calculated this out in previous video notes, and we found that momentum of this particular object would be 200 kilograms times meters per second. But let's see what's going to go on. So this cart is going to move, and it's going to collide into a stationary 5 kilogram triangle cart. All right? So if it's stationary, meaning it's stopped, its momentum, its velocity is 0. So the overall momentum of this collision, all right, once it hits, okay, is going to be the same as the overall momentum before it hits. So before it hits, we have to calculate the momentum of each object. Okay, so 20 kilograms times 10 meters per second. And how do I get that? If you remember, we have momentum equals mass times velocity. Okay, so the mass times velocity. So this is 200 kilograms times meters per second for the square cart. All right, the triangle cart's a little bit easier. It's 5 kilograms times 0 meters per second. You know, 5 times 0 equals 0 kilograms meters per second. You add them together, the total momentum of this system is going to be 200 kilograms times meters per second. Okay? So after they hit, we have a before the accident, after they hit. Okay? If they hit and the square cart stops, okay, it's going to send the triangle cart moving. So now the triangle cart remember it's 5 kilograms. It's now going to take off moving toward the right. Okay? Now, we can actually calculate how fast that cart would be moving because we could say, look, before we had an overall total momentum of 200 kilograms times meters per second. Okay? So now, if this cart is stationary, we have 20 kilograms stationary. Okay? We know that its momentum is 0 kilograms times meters per second. So now, if we know the overall momentum of the system is 200 kilograms meters per second, it's all wrapped up in the motion of that triangle car. Okay? So 200 kilograms times meters per second equals 5 kilograms, which is the mass, times its velocity, which is our unknown quantity. Now, how do we calculate that? Well, we're given momentum and we're given mass. If you look up to our formula triangle, okay, you'll see it's momentum divided by mass equals velocity. So if we divide 200, so it becomes 200 kilograms divided by, times meters per second, all right, divided by 5 kilograms, you're gonna find that 200 divided by 5 is 40 meters per second. So you can see that in this collision, okay, in the absence of friction and gravity, you're going to have equal amount of momentum before the collision and after. Okay, and then you can, based on that knowledge, you can calculate the overall velocity of the carts after they move. This is a lot of times involved in accident reenactments. Okay, they measure skid marks, they find the speed, they measure friction. All right, there's a lot more detail involved, but this is the basic foundation upon which that is based. Okay, so that's really the basics of conservation of momentum. You have the same amount of momentum before the collision as you do after the collision. Okay? If you have any questions, please bring them to class. As we circulate the room, we'll be happy to answer any questions for you. Okay? Have a good night.